But how is seawater made drinkable? In regions where freshwater is limited, desalination plants remove salt from seawater, transforming it into drinking water suitable for human consumption. This plant converts 7 million liters of salty seawater into drinking water every day. There are more than 19,000 desalination plants worldwide that produce over 45 billion liters per day. The desalination plant that produces drinking water is located next to a power plant that uses seawater to cool its condensers. After cooling them, the water travels through underground pipes to the desalination plant. The plant makes seawater drinkable in just 90 minutes, surrounded by the sea on 3 sides. Here, there is no shortage of salty water. The challenge is how to make it potable. The water is treated in a multi-phase process before salt extraction. The desalination process begins with the intake of seawater through open intakes. A strategic location is chosen to ensure a constant supply of high-quality seawater and minimize environmental impact. Seawater is drawn several hundred meters from the coast. Grates and filters block large floating objects and prevent marine life from entering. A 63-centimeter diameter pipe extracts 15 million liters per day. That's more than 10,000 liters per minute or a bathtub every second. At the intake, pumps are needed to push the seawater to the plant. As seawater is drawn in, some unwanted visitors appear: mollusks, jellyfish, crabs, and sometimes small fish. To prevent these small creatures from coming out of our taps, a giant grate screens out anything larger than 4.5 millimeters in diameter. The water passes through screens that filter out larger debris. Even after these creatures are removed, the water is full of small particles of suspended sediments. The solution is a process called filtration, which takes place in these tanks. Water particles pass through sand beds by gravity. The gaps between the grains are so small that only water can pass through, leaving behind any suspended particles. The sand moves downward against the water, and dirt particles stick to the sand. It may look clean now, but it still contains microscopic particles. Every particle larger than 1/10 the thickness of a human hair is removed. Next, large paddles stir the water, and the plant adds 2 chemicals: sodium hypochlorite, a disinfectant, and ferric chloride, a coagulant. The coagulant binds the waste and sand, forming larger clumps that sink. A large portion of the dirt is removed from the water, but it's still far from crystal clear. The water then moves to a set of basins for the second phase of pretreatment. Inside each filter, a constant stream of air spins the sand in circles, finer than regular sand. It filters out microscopic particles. The seawater is temporarily stored in giant tanks of 500,000 liters. It is now clean and ready for salt extraction. Salt is very difficult to remove from water. It is naturally attracted to water molecules, so to purify it, this attraction must be eliminated. Next, the water is separated from the salt through a process called reverse osmosis. Here's where the magic happens. The secret to removing salt is pressure. This is a centrifugal pump. Each of these components manages the pressure. The water enters the centrifugal pump, and the pressure increases as it moves through the stages until it comes out the other end. After the seawater has been pumped under high pressure, it enters reverse osmosis units equipped with semi-permeable membranes. These membranes are critical in the desalination process, as they allow water to pass through while retaining salts and other impurities. The plant pumps the salty water under high pressure through these tubes, each containing 8 membranes. The seawater flows through the semi-permeable membranes in the reverse osmosis units. These membranes let water molecules pass but retain most of the salts and other minerals dissolved in the seawater. The cylinders contain layers of plastic sheets with pores 1,000 times finer than a human hair's diameter that trap the salt crystals. Water molecules, being smaller than salt and other impurities, pass through the semi-permeable membranes and are collected as purified water on the permeate side of the reverse osmosis units. This purified water has a significantly lower concentration of salts and other contaminants than the original seawater. When the water passes through all the membranes and reaches the center of the tube, it is salt-free. The salts and other impurities rejected by the semi-permeable membranes accumulate on the feed side of the reverse osmosis units, forming a concentrated brine stream. This brine, which contains a high concentration of salts and other minerals, is removed from the system and properly treated. 99.8% of the salt is removed, and what comes out is pure water. The desalinated water is collected from a pipe. 2 liters of salty seawater produce 1 liter of fresh water and 1 liter of water with double the salt concentration. The plant staff monitor each of the 10,000 membranes in the system. Meanwhile, the previously removed waste is sent to large basins for another phase of chemical treatment. When the solids settle at the bottom, the dirty water returns to the beginning of the plant to be cleaned and recycled. Pressure rollers squeeze the remaining water out of the solids, which are then transported to a landfill. Meanwhile, the extracted salt goes back to the power plant, where it is diluted and returned to the sea to avoid affecting the water's natural salinity level. After reverse osmosis desalination, the purified water may have a different pH than optimal for human consumption. Therefore, it may be adjusted by adding acids to reach a suitable and safe level for consumption. Water desalinated by reverse osmosis may have a lower concentration of essential minerals compared to conventional drinking water. To improve its taste and quality, small amounts of mineral salts like calcium and magnesium can be added through a process known as remineralization. This helps balance the water's mineral profile and provides health benefits. These elements regulate the pH level and increase alkalinity. This way, it recovers minerals at its natural taste with minerals in solution, making the water suitable for consumption. The only thing left is to treat it with chlorine to prevent microbes from appearing. Although the purified water has already undergone a disinfection process during pretreatment, additional disinfection is essential to eliminate any bacteria that may have survived the desalination process. This is achieved by using chlorine before distribution for human consumption. The purified water undergoes thorough testing to ensure it meets the quality standards set by regulatory authorities. These tests include analyzing parameters like turbidity, dissolved solids content, presence of heavy metals, and concentration of residual disinfectants. A computer controls its chemical composition to ensure it is drinkable. Once the purified water has passed through the post-treatment process and its quality has been verified, it is distributed to consumers through the drinking water distribution network. This is one of the 20,000 desalination plants worldwide that supply water to over 300 million people in just 90 minutes. The water has traveled from the ocean to the city.